Okay, so today we're going to learn about vectors. So, go ahead and draw my graph. We have 2 points up here, and it says express this vector in component form. Component form is when you essentially have coordinates, A and B, but you don't use parentheses. Instead, you use these triangle things. Okay? So we have 2 points, 4, 2, and then 1, negative 2. We draw a line in between them. And these components tell us how the coordinates changed in going from this point to this point. So what we're going to do is subtract the x values from one another, subtract the y values from one another, and that's going to give us our components. So we're going to have a equals x2 minus x1. x2 is 1, x1 is 4, so a is going to equal negative 3. And then b equals y2 minus y1, or negative 2 minus 2, which equals negative 4. So when it says to give the component form, that is what it means. This explains how the point goes from here to here. Next it says to draw an equal vector, v, meaning equal to this line, in standard position. Standard position means starting out from this point. So what we want to do is go from this point 3 back, because that's our x value, and then 4 down, because that's our y, and then that is an equal vector. Okay? And the next example says state the magnitude and direction of PQ in example 1. And that's going to be pretty easy because we already have a formula for that. And the formula is the absolute value of the vector equals the square root of a squared plus b squared. And we just plug that in. So the square root of negative 3 squared plus negative 4 squared. So 9 plus 16. 9 plus 16 is 25. The square root of 25 is just 5. Now you might say it is positive or negative 5. But because we're taking the square root, the absolute value, it is only going to be positive 5. So that's magnitude out of the way. Now we've got to look at direction. Direction is expressed in terms of theta. Sorry, an angle. And it's actually in terms of alpha at first. And what alpha means is how far this is if we drew like an imaginary line across the y-axis. And alpha is going to equal arctangent of the absolute value of b over a. So we plug this in. B is 4, negative 4. A is negative 3. Plug this into a calculator, and we get that alpha is 53.1 degrees. Oh, I told you wrong. I want to make sure I get this right. Alpha is this, from the x-axis to the angle in standard position. Now theta is different. Theta is represented as the entirety. If you had a line starting at this side of the x-axis and rotating back to this angle, what would that be? And so, of course, this is 53.1. This is 180. So to find theta, what we have to do is add 53.1 to 180. And from that, we get 233.1 degrees. All right, so next we'll be introducing some new terms, the vector sum, where you add the vectors, and then the scalar product. So scalar product, you just have one number in front of the components that you multiply both components by. And then if you have a vector sum, you add the components together. For instance, in this right here, it says to add u and v. So we're going to take our x terms, -2, 6, and our y terms, 1 and 3, and add them together. So -2 and 6 equal 4, 1 and 3 also equal 4. So that is our new vector. So that's that done algebraically. And before we do it geometrically, I'll go over here and do this one first. So this is a vector sum, this is a scalar product. 1/3 and 2, -2, would be the scalars. You don't have to apply the -2 yet because we're going to subtract later on. So we can think of it as 1/3 times 6/3 minus 2 times -2, 1. So this turns out to be 1/3 times 6 is 2, 1/3 times 3 is 1, 2 times -2 is -4, 2 times 1 is 2. And then we just subtract like we did beforehand. So 2 minus a -4 is a 6, and 1 minus 2 is a -1. Your book does multiply the negative. You can do it either way. But this is going to be both of your algebraic answers. Now to solve it geometrically, we're going to start out in the original position, in the standard position. We're going to go back for this problem to our first point. So -2, 1. And for organization's sake, I'll label this as u. The next point we have is 6/3. And for organization's sake, I'll label this as v. We're going to go this way. And then our resultant vector, or a vector sum, is going to be labeled r. That is this point from here, the original standard position, to here, the vector. Then over here, we're going to start out in standard position again, but instead of using the originals, we're instead going to use the scalar products. So 2 and 1. And then -4 and 2. Oh, excuse me, because they multiplied the negative, the signs changed. And then this becomes a positive. So I will have to graph this. So +4 and -2. So it goes down. So this is u, v, and then our r will be this line from standard position to where the end of the vector is. Okay, example 4. Find the unit vector in the direction of v equals 3, negative 5, and verify that it has a length of 1. So first we're going to find the magnitude of v. So the absolute value of v equals the square root of 3 squared plus negative 5 squared. And this is going to equal square root of 34, positive square root of 34. The next thing we're going to do is find u, the unit vector, in the direction of v. So we're going to say that u equals 1 over the absolute value of v, which is the magnitude, times v itself. So 1 over root 34 times the components 3, negative 1, 5. And that's going to give us, when we order everything due to the radical being on the bottom, 3 root 34 over 34, negative 5 root 34 over 34. So then we can find the magnitude of this. So the magnitude of u. Plug that into a magnitude formula. We have 3 root 34 over 34 squared plus negative 5 root 34 over 34 squared. That is going to give us the square root of 34 over the square root of 34, or just 1. Okay, well, 2 more examples to go. Example 5 says, write PQ with initial point P, negative 2, 5, and terminal point Q, 9, negative 7, is a linear combination of standard unit vectors. So the first thing we're going to do is find the component form of PQ. We're going to subtract 9, which is x2, and negative 2, which is x1, and then y2 and y1. That is going to give us 11, negative 12. And then we're going to write PQ as a linear combination of I and J. So this might be confusing. Why do we use I and J? If you look back on page 289, it says the standard unit vectors I equals 1, 0 and J equals 0, 1 can be used to write a vector V as a linear combination of its horizontal and vertical components. So essentially, every time you see linear combination, that's what it wants us to do, is to just write it in this weird form. And it goes back to some three-dimensional math that a guy in England developed back in the 1800s. So 11 minus 12j. This is kind of another way of expressing three-dimensionality without having to refer to imaginary numbers. And then finally, example 6. We're not going to do example 7 or example 8. It says resolving a vector into horizontal and vertical components. State the component form of a vector representing the velocity of a plane flying 30 degrees west of north at 400 knots. Then express the vector as a linear combination of the standard unit vectors. So linear combination meaning I and J. The first one is easy. It just tells us to express a vector. So we kind of eyeball this. 30 degrees west of north. So obviously the y-axis would be north. West would be left. We know our vector equals 400 knots. That's pretty easy. Next we need to find theta. Remember, theta is from here to here. So we don't have 180 degrees anymore. All we have is 90 degrees. So we just take 90 degrees, add 30 to it, and we get 120. That's our theta. And then lastly, we actually have to do math to get to our component form. The way we get to our component form is we're going to take our magnitude, 400, and multiply it by cosine of theta, because cosine relates to our x values. Next, we're going to take our same magnitude, 400, and multiply it by our sine theta. And when we plug that into the calculator, we're going to get negative 200. And I'm just going to put it in this simple form, 200 root 3. 200 times root 3. There is a decimal form that you can write it in as well. Now, of course, if you're actually going to use a unit circle, which you can, you would get a certain certain x and y values for these two that you would have to plug in and then multiply by 400. So cosine 120 would be negative 1/2, and sine 120 would be root 3 over 2. So now that we have it in this form, all we have to do is put it back here. So negative 200 I plus 200 root 3. And that's going to be it. So hopefully this was a lot easier than last week. Thank you to Mrs. Herndon for actually filming this. And I'll see you guys tomorrow.